All right, class. I'm just thought I'd get you a quick video on factor by grouping level four. Just some extra details to handle kind of like all the possibilities on this type of factoring. All right. One thing I want you to notice that whenever you're dealing with factor by grouping, the powers have to go down kind of by one. So 3 to 2 to 1, and there's no x there, so we call that x to the zero. So as long as you see that, that might be a case for factor by grouping. But I'm going to emphasize something here, and what I'm going to use is called the reverse multiply box method. And those of you who've seen my notes who are in class, you know what that worksheet is, but I'm going to apply it. And the technique is that when you look from left to right, you write in what is called a Z pattern. And so you start with the highest power and you put the 6x cubed, then you put the plus 10x squared, then you put the negative 9x, and then you put the negative 15. All right? Now, the key on the first part here is that you want to look for the greatest common factors in a down direction. So let me kind of use that, and there's a little transparency feature. Good. And so we're looking for the greatest common factor going this direction. So my mind says, okay, what numbers go into 6 and 9? Well, technically a negative 9, but we're looking for positives because it's a positive 6. So I'll say the greatest common factor is a 3. 3 divides into 6, and 3 divides into the 9, and it's the biggest positive integer that works. Now, how many x's can we factor out from an x and x to the third? Well, we always factor out the smallest one you see, that first power. It's hidden, but it's a 1, and so you're going to write 3x. Now you do the same thing over here. You say what goes into a 10 and what goes into 15. And the biggest positive number that we can think about is the positive number 5. All right? And is there any x's that we can factor out? Well, we can factor out some x's here, but there aren't any there. So if there's not any there, we cannot factor out any x's here, and we leave it alone. Now, the next part of the situation is you look across. But this time, when you look across, you're not looking for the GCF this time. You're looking for a common factor that when you multiply to this 3, you'll get the 6. So you think about it and you say, well, what do I multiply to 3 to get 6? Or how many times does 3 go into 6? And your mind should quickly say 2. Then you say to yourself, well, what do I multiply to x to get x to the third? Well, if you already have one of the x's and you need a power of 3, well, that means you need a power of 2 to multiply to the power of 1 to get the power of 3. Of course, because 1 plus 2 makes 3 when you multiply. Now, here's the thing. You have to check. 2, now the check is the second column. 2 times 5 is 10. That checks out. X squared times a hidden 1. The hidden 1's always there. That times 1, nobody ever writes it, but it's there. And you say, well, x squared times 1 is x squared. You're good to go. All right, next. You say to yourself, what do you multiply to 3 to get a negative 9? Well, hey, if we need a negative, we need a negative 3, because negative 3 times the positive 3 is a negative 9. Now, we say we have x to the first. What do I multiply to this negative 3 to get x to the first? We already have an x to the first. So we don't need an extra x, so we leave it alone. But we have to check. What's a negative 3 times a positive 5? Ooh, that's negative 15. Everything works. That means we have our factors of the reverse multiply box. And basically, you can say that this equals 3x plus 5 times 2x squared minus 3. Now, for now, we consider this factored in the integers. You're not going to be able to break this 2x squared minus 3 down, but it is factorable in the reals, and I did tell you about level 4, so I'm going to show you how to go further. The best way to think about this is that on the previous video, I talked about differences of squares. So I want you to think of it that we wrote it down here. So I'm going to write it down here. 3x plus 5 times 2x squared minus 3. And this is where you get to the advanced part. And it has to do with this 2x squared minusing a number. I don't know if you saw my difference of square videos, but you don't know if two whole numbers that multiply to 2 that are equal to each other, that get you a 2. It's 2 times 1. 2 and 1 are different. Same thing with 3. 3 times 1. They're not the same. But there is a technique called square rooting, and I'm going to show you this technique right now. I think some of you can figure this out. It's the square root of 2 times x times the square root of 2 times x. That's pretty tricky, right? Whoa, square root of 2. Well, that's true. Square root of 2 times square root of 2 gives you the number 2. So that's a special number. It's a radical number, a square root number, but it is a number, and so that's legal in mathematics. Same thing goes with this 3. You can still get a square root of 3 times the square root of 3. So you say, whoa, I'm noticing a pattern here. All you have to do is square root this number. If you happen to know the whole number, that's great. But if you don't get whole numbers, you leave it alone. And this tells us that the final factored form is 3x plus 5 times parenthesis the square root of 2x minus the square root of 3 times the square root of 2x plus the square root of 3. And like I said, this is big time level 4. This is honors level factoring in Math 3. So I'm giving you a little taste of it. I know all of you can figure it out. Replay the video. And if you don't understand this difference of squares, go check out my difference of squares video. That will help you. Hey guys, thanks for watching.